stand. Yeah. I don't know why it's not good.
Wait.
Including the different stations. Just make sure that you open up so that she can take what we are doing. Okay, we're also going to need a watch bottle. That I'm going to have to look for it. A watch bottle there is the same as the squeeze bottle. It's a bottle that you squeeze, you put water inside. Just check them if it's not there. There are chemicals in there. You may find one there. So we'll need that as well. So inside here, remember we still have the normal water, tap water. So this is not distilled. This still needs to be washed with distilled water. So we still need to fill the water inside. Now normally when you fill the water here, sometimes you need to climb up the chair because your eyes need to be fixed to this position here. You can't make a mistake when you fill the water. You may use a funnel, but it's dangerous to use a funnel. So you need to constantly lift it up because once the pressure is exerted on the funnel, then you may have a problem because the liquid may go past that point, which is not allowed in our chemistry. So just make sure that we do the right thing. Are you finding the squeeze bottle? It's a bottle, it's an empty bottle, it's white. It's just white and then it has something at the top. It has a tube at the top where if you squeeze water can be out. It looks like that, but it's bigger than that.
Whoa. You're disturbing me. Everything is not prepared. Still mixed up. Yeah, guys.
So you need to make sure that all the chemicals are there, right? It would have been nice if we have 2 watch glass, but it doesn't matter. Once you've done the weighing with this one, you can then clean it. Okay, I just want to show you what we do, right? How we prepare the standard. Because when you do the titration, you come here, right? You would have the standard inside here, which you would have added water to the mark. Can you all see there's a mark here? Yes. What you do is you put a little bit, the powder that you would have weighed from the scale, right? You put it inside here, no? With your weighing scale. So in other words, but you see you can't take this and put here. Can you see that this hole is smaller? Yes. So what you do is you take your funnel, right? You put it inside here. Then you clean this thing up. Obviously you find this thing will be on the floor, right? Then what you do is you take your squeeze bottle, you clean this thing up, right? The entire thing, you make sure that it goes inside. Put a little bit with your squeeze bottle, right? Then make sure that the entire solid is washed inside this, right? Immediately after that, once you are satisfied that your funnel has nothing left in it, right? Because you must not lose anything. Then you can remove your funnel, put it aside, right? What you're going to do after that, you then reach out for your distilled water, which is here. Still called petrol water, it's fine, right? Then you're going to use your distilled water again, right? If it's still inside here, then it's fine. You can continue to use it. Now, you have to be careful then now because after that, you add a little bit, right? Just a small amount. Just make sure that you are able to dissolve the powder inside, right? Dissolve it. And once it's dissolved and you can't see any particles of powder, then you should then be satisfied. Once that happens, you must now continue to add distilled water, whether with this or a beaker or whatever, doesn't matter. You add it up until you reach the mark. It must not pass this mark here. Once you reach this mark here, there will be a meniscus. You see the curve I was talking about in that. When you reach that curve there, then you stop. Ne? That is now your standard. You put this thing aside. Ne? If it's sodium hydroxide, then it's sodium hydroxide, right? Done, finish. You come now to the second one, because before you can start the experiment, you need to make sure that all your standards are here, all your standards are done, right? Using the instrument, of course. Now you come to oxalic, right? You do exactly the same thing. You take your watch glass, clean it up, make sure it's cleaned up, right? You can use your distilled, wipe it with your tissue, and once you are satisfied, put it back here. Of course, you will do your measurement right here. Now, chances are that when you apply the scale here, the scale may not give you the exact measurement of the powder, right? That's why you need your paper to do calculations, because the scale is going to pick this up, right? And the scale is going to also pick up the powder as well, right? So you need to weigh this first, get the mass of the watch glass first, record it, right? Then get the mass of the watch glass with powder, right? Then from there you can do your subtractions, ne? Then it will give you the exact mass of the powder that you need, right? Before you can then do the transfer, right? If it doesn't work, and then we just do our estimation, and then we continue with the experiment, right? Then from there, once you've done that, you do exactly the same exercise again, right? You come back again with your powder, which is oxalic, right? Put in your funnel again, and then from there, put it inside, clean it up with your watch glass, right? Make sure everything goes inside here. Now, this is the second standard, right? Yes. Make sure everything is washed in, then it goes inside. Once you are satisfied with that, remove your funnel, right? Then do what now? Take this again, right? Yes. Fill it up until you reach the mark. Can you see in both of them, the marks are not in the same place? Yes, but they are equal in size. Yes, they are equal in size, so that matters not. Because you can see this is thicker than that one, can you see? So that is not an issue at all. You fill this thing up until you reach the mark. There is the mark, right? Then now, what do you have? Two standard solutions, right? It's sodium hydroxide and oxalic sorted. Now you are ready to perform your experiment. Then you need to go to the next step. The next step then says, out of this is a conical flask, right? This is also an Erlenmeyer flask. That's the name of it. You must know those names. Conical flask, Erlenmeyer flask. You don't know the spelling, it's written there in that paper. It's a 250 ml, right? Now inside here, right, you only put the acid, right? We titrate using sodium hydroxide. So in other words, we add sodium hydroxide on top of the acid. So what we do in this Erlenmeyer flask, now we come back here, right? What do we do out of that? We take exactly the measurement that we need, right? The method says pour a standard solution, right? Of oxalic that was prepared in part 1 of the 125 ml beaker, right? And we're not going to use a beaker. This is what we use, right? We use an Erlenmeyer flask. So what we're going to do here, we're going to transfer 25 ml, right? Now I said to you, let's prepare 2 burettes so that we are able to do what? Use one for oxalic and use one for sodium hydroxide. So when we have oxalic there, we're going to fill up 50, right? But we're only going to take 25 ml. Don't worry about the scale. That is already in mils, right? So it's already sorted. So which I must just make sure that it's clean. We clean it with distilled water. We make sure there's nothing inside. So once we've done that, then we are sorted, right? So we'll have 50 ml of oxalic acid. This one will wait for titration. Now the procedure is as follows. So out of that, you will take 25, right? And that 25 goes inside here. Unless you look at the scale, you will check the mils there. Once you get to 25, which is half of 50, you then stop, right? Immediately after that, there's an indicator that you must put inside here. And I want you to watch carefully what I said yesterday when you put the indicator, right? Look for that color change that comes and then it fades away, right? And then from there, you'll be able to tell also the colors. You will see that when you put the indicator inside, the acid remains colorless, right? But the moment you start putting the standard, you may then have a color change. Once color changes, then you stop. Then it means what? It means that the acid has been neutralized. That color change, the new color that you find, right? It means that the solution that you have now is now basic. It's no longer acidic, right? That's how you do it. Indicator, you can put 8 drops of it, right? The name of the indicator is phenolphthalein. Phenolphthalein, the name is also there as well. You can capture it for your own information and knowledge, right? Titration is easy because I'm sure the standards would have been done. And then everyone can have an opportunity to do their own, right? And titrate and do all of that. Now, I also need to educate you on the procedure of the titration itself, right? Now, the titration itself requires that you become skilled in opening the tap. So this must sit proper according to the hand that you use. If you are a left-hander, it means the tap must be on your left. Then this must be on your right. So in other words, if you see here? This is sitting right on top of this, can you see? And this must go a little bit down because it's too high. Otherwise you'll miss the liquid. So now, if I'm a left-hander, I'm going to show there's a liquid inside here. So I will open the tap, right? You see, I'm opening the tap. Can you see what I'm doing? What am I doing? Shaking to mix. I'm mixing the base and the acid. Yes. So then I continue to open, right? Can you see that I'm shaking? I'm shaking, right? Once the color change, I close the tap and I stop. That's now a basic solution. No longer an acidic solution. Right? That's how titration is done. So that's how we're going to do it. So we need to make sure that our purettes are working proper, and that one purette is also working proper as well. It's not releasing anything. And then from there, now another thing that I need to explain, and somebody will then ask, how do you then transfer the indicator, right, to the liquid? Because you will have an acid inside here already, right, which is 25 ml. How do you transfer that inside here? It's easy to do it, right? All you do is you pick up your syringe, right? Then you go inside the container of the indicator, right? You draw the liquid in there. Then you put in by drops, right? So it's 1, 2, 3, 4, 5, 6, 7, 8. If it's 8, if the method requires 8. Actual method differ in different materials. Some will require 4, some 6, some 8, some 10, right? But I want you to observe, even if you can't observe it yourself, but those around you need to observe as you put the drops in, right? There's a slight color change where the drop lands. Then the color fades away immediately, right? So those are things that you need to be aware of. So that's basically how the experiment is. You see? It's not a difficult experiment, but we need to make sure that things are working proper. I can see this one for titration is working proper. I'm not sure if that one has been tested. Is it fine? We need to get another one. There's another one there. Get another purette. There's a purette there. Inside this. Inside that box, there's another purette there. So we need to get that. And let's just make sure that the liquid can come out nice and easy. Right. Now, you are going to start. Let's get the instrument and see if the instrument is working proper. We are looking for 3,2. Right? Now you will know. Let me make an example. If you're looking for 3,2 grams, right, of oxalic acid, okay. No, this one we can measure 4 grams of sodium hydroxide, right? 4 grams will be fine. Yeah, it's 6 to 8 grams, né? That's what the method is saying here. 25 ml of oxalic acid into a conical flask. Conical flask, of course, is this one. And then rinse the purette with some sodium hydroxide. Yeah, you see? Before you can use this, I'm going to show you rinse it with distilled water. That's not good enough. You must still put what? A 50 ml, which is going to be wasted. Because you need to clean it and make sure there are no impurities. So what you're going to do, you're going to put 50 ml of sodium hydroxide once it's prepared, right? Then from there, what you do is, give me that other burette so that I can show how you clean it up. Thank you. Now, normally when the tap is in this position, it's closed, right? When you take it to this position, it's open, then the liquid flows through, right? Okay, but it depends on the setup, but it should be like that. So what I want to explain to you is how do you then clean this, right? Let me assume that I've already placed sodium hydroxide inside, right? Then all I'm going to do is I'm going to close it, right? Okay, then I'm going to close here with my finger, right? Then I'm going to turn it upside down. Can you see what I'm doing, right? I can do this if I'm able to do it, right? That's fine. Then at the end, what do? Open it, right? Release the entire, make sure there are no bubbles here. Release the entire liquid, right? Then I'm sorted. It is now clean, right? Because I've placed sodium hydroxide, so you cannot expect to have any contamination of some sort, right? Or any mix-up. Then from there, you are sorted. Then you can now fill up sodium hydroxide up until that mark of 0. Then you are ready for titration. So the nice thing about this is that we can prepare as many as we want. I see 1, 2, 3. And then, of course, we can add more so that everyone has a touch. And then they experience what is happening there, right? I hope Oxalic will not disappoint us. I'm not sure how old it is. Otherwise, we may have to use a new one. But that one I know is new. If it's too old, it sometimes does not give accurate results, right? I want us now to explore the instrument and let us see if the instrument will be able to serve the purpose. Now, normally this is calibrated, right? Okay, you can go to mode. We need to set it up to grams. So just touch the mode until it gets to grams. Is it in grams? But it should be clear. It should say 00.
Then please switch it off again. And then, yeah. Oh my God.
But 00 in grams, ma'am. Just set it up. You don't need to switch it off.
How do I
Just set it up. Go to mode.
It is.
Go to mode. It must be at 0. Just go on.
It's still 1.6. Oh,
Okay. So now it's sitting at 0, right? Now, I'm just demonstrating. You will do yours just now, right? Let's put this thing inside. Somebody must be writing. This is the mass of watch class, né?